solve. So we have here for a, x cubed minus 3x greater than negative 2x squared. So the idea here, when I see these x squareds and x cubes, I want to get everything over to the same side. So I'm going to add 2x squared to both sides. And another thing I'm going to do when I actually add it to the other side, I'm going to put it in descending powers. So that means I'm going to put the 2x squared after the 3x squared, and then the minus 3x on the end, and that's going to be greater than 0. So we always want to get it to a point where it's greater than 0, less than 0, because now we're talking about the x-axis, and that's the important thing here. So now we can visualize above the x or below the x, and also including the x-axis if it's equal to. Okay, so now what I'm going to do here is factor. So I look here, I can factor an x out of everything. So that's, I was going to put x cubed, that's x squared, plus 2x minus 3, and that's greater than 0. So this inside I can also factor, and that's going to be x, and then this is going to be x plus 3 and x minus 1 greater than 0. And I pick the positive negative here because that's a negative on the end there, so those have to be different signs. It's the first thing I noticed. And then the other thing I noticed was the middle term's positive, so that tells me here, that the bigger number has to have the positive. So that's how I knew that, how to factor that right away. Okay, so anyways, let's get on with the problem here. So now, like we did in the last video, we're going to do this one completely algebraically. We're not going to graph it. We're not going to go through any of that. All I'm going to do is create my number line. And in creating my number line, I'm going to pick the values that are the zeros for this polynomial, which means where my points are on the x-axis at. So the x-intercepts. So we see that we have one at 0 here. And that's that one. So put that here. We also have one at negative 3, because negative 3, if I plug it in for x, is going to make that 0. So negative 3. And then we also have one at positive 1, because 1 makes this 0. Okay, so now that we have all three of our points on there of where the graph could possibly change from positive to negative or negative to positive, now we can go to the left and to the right of those. So what I'll do is I'll pick a different color here so that can emulate what those other values are going to be. So this is going to be negative 4. We'll pick negative 4. We'll pick negative 1. And then we'll pick 1/2. And then we'll pick 2. And all I'm going to do here now is just go through signs of my numbers. I don't have to know the exact values. I just have to know if their answers, when I plug them in, are going to result in a negative or positive number. That's all we care about here. All right, so first things first, I'm going to plug in the negative 4. So for the x here, this x out here, it's going to be negative. So I'm just going to write negative. And then for this x plus 3 here, when I plug in a negative 4 for x, it's going to be negative. And then negative 4 for x here, and we could see that that's going to result in a negative. Negative 4 minus 1 is negative 5, if you were confused about that. So that's also going to be a negative. So we have an odd number of negatives. So we know that this here would be negative. And remember, I said that in the last video, because every pair, if I times them, is going to give me a positive. So if I have one left over, that's always going to result in a negative. So that's how I know when I have an odd number of negatives, it's negative. So just keep that in mind. All right. Now let's move on to the second test point here. That's this negative 1 here. So I'm going to go and plug negative 1 in for x. And that's going to result in a negative. I'm not going to put the 1. Then when I plug in a negative here for the second one, that's negative 1 plus 3. That's going to be positive, because the positives are larger than the negatives there. And the negative 1 here in the last one, negative 1 minus negative 1, that's going to be negative 2. But just negative we care about. Okay, so anyway, so I have an even number of negatives, so that tells me it's going to be positive there. And then now the third one. So then for the third one, the 1/2. So 1/2 is going to be positive here. The The 1/2 is going to be positive here, and the 1/2 is going to be negative there because 1/2 is smaller than the -1 there. So that's going to be negative because I have one negative. And then for the last one, the 2. So positive, positive, and positive. So it's positive. So now we have all the information we need for this one. I like to write them all out. Now, when I look at this, I know we're only looking where it's greater than 0, which means where it's positive at. So those intervals now become apparent in this. So if I'm positive between the -3 and the 0, and it's not equal to, so I'm not including it, so I'm going to use parentheses here. I'll put -3, comma 0, union. And then now we also have after 1, it's positive. So after 1, it's positive, so I'm going to write 1 to infinity. So that's our answer for this first one. Again, it takes a little bit of time to get there, but once I get that plus minus sign thing going on, it's pretty fast. Now again, I don't usually write all that out, so it's a lot faster when I go through it. I just write plus minus plus 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 plus, whatever it is, and then from there I'm pretty quick about it. So I think you could get the same way if you practice just a little. Now let's take a look at B. B is a little bit different because you might not see the actual function that you're actually dealing with here. So what I'm going to do here is I'm going to move everything over to the same side. So I'm going to subtract this 6 over x. So this is going to be 6x minus 6 over x minus 5 less than or equal to 0. So now what I have to do here when I have one that's a fraction and have an x on the bottom there is I have to build them all up so that they all have x's on the bottom. So that's how I have to deal with these. So that means I'm going to have to think about 6x over 1 and 5 over 1. And I got to multiply the top and the bottom of those by x for both of those. And then what we'll end up with is 6x squared over x. And I'll put this here on the end. And again, you might not realize that right away, and I didn't, and that's okay. You can always switch them around as you get this. And then minus 5x over x. And then minus 6 over x. Less than or equal to 0. Okay, now the next step then is going to be, remember how addition of fractions works. If the denominators are the same, I just add or subtract the numerators over the same denominator. But here, I can't really add those together because they're not like terms. And I only can add or subtract terms that are like terms. So I end up with this as my answer. So far. It's not my answer, but this is what I end up at. Now that I have this, I'm going to factor the top. Because now I'm going to do the same thing I did with the last problem here. But I have to be a little careful because I got top and bottom now. And I'll have to take into account each factor in both the top and the bottom when I go through this process. And I did that in the last video too, so if you're concerned about that or want to see more examples of that, at the end of the last video, I talked about this idea. So if you just want to cut through the chase, you can go to the end of the last video and you'll see how this works if you want to see another example. Now the factoring can sometimes give you a problem. If it does, get a hold of me. We can do some Zoom meetings on that if you want. But the top is going to end up being 2x minus 3, 3x plus 2. Then on the bottom, I just have an x down there, and that's going to be less than or equal to 0. So now, since everything's factored, we're just going to go through the same process like we did with part A here. And we're just going to run through the plus and minuses. But we're going to label on our number line all of the zeros, which means where the top is 0. And where the top is 0, those are x-intercepts. And where the bottom is 0, that's the asymptotes. So now, and I'm going to put those in different colors. Right now, I'm going to just change my bottom variable to an x, a red x, because I'm going to put that one down first. And that tells me I have an asymptote at 0, x equals 0. So I'm just going to write it there, just so it's very clear that that's my asymptote. Because again, if we're butting up to that value, I'm going to have to use a parenthesis because asymptotes are not included in the domain, those x values. So just keep that in mind. All right, and then what I'm going to do is I look at the top now, and what makes that 0 is 3/2. And if you can't see that, you can simply go, hey, 3x or 2x minus 3 and set it equal to 0, and then solve this. So that means I would add 3 and divide by 2. So that would be 3/2. If you can't see what I just said immediately, you can always do this and set it equal to 0, find out what it is, and say, oh, that 0 is 3/2. And that's fine too. All right, so I'll put 3/2 on here. And then the other 0 is this one here. That's going to be negative 2/3. And again, just go through the same thing if you're not convinced. Okay, now we're going to pick all of our test points here. So here we got negative 2/3. So I can pick negative 1. That's smaller than negative 2/3. In between 0 and 2/3, I don't really like this number. I can pick negative 1/2. And that's okay. We're just testing for positive or negative anyway. So if we had to plug them in, I would probably like it less. And between 0 and 3/2, I can pick 1. And again, I have to have some understanding of fractions to actually set up these points here, or these values. So keep that in mind. And here I can go to 2. Because I know 3/2 is really just 1 and 1/2. That's why. So that's why I can pick 1 on one side and then pick 2 on the other. And I know 2/3 is between 0 and 1. All right, so that's how I set all that up. So anyways, this might be your biggest confusion right here with negative 2/3 and negative 1/2. You just have to understand a little bit of fraction order. So anyways, let's get started with this problem then. All right, so now for the first one, if I plug in a negative 1, 2 times negative 1 is negative 2. So, and minus 3 is going to be negative. Okay, negative 3, that's going to turn out to be, plus 2, that's going to turn out to be negative. And that's going to be negative down there. So that tells me when I plug in negative 1, it's going to be negative because I have 3 negatives. And 3 negatives leaves me an extra negative. Okay, so it works with division as well. So it doesn't change anything because multiplication and division are very similar operations as far as the structure of it. They're the same. So anyways, let's deal with the negative 1/2 now. So negative 1/2 times 2 is negative 1, minus 3 is negative. Okay, negative 1/2, so that's going to be a negative 3/2, which is negative 1 and 1/2, and that's 2, that's going to be a plus. That's where it becomes a little more difficult to do these with this process right here, because it's fractions. And then negative down here, because negative is negative. So I got an even number of negatives, so that means it's going to be positive. Okay, now the 1. Now we get a little easier here with the 1. So that's going to be 2, and then minus 3 is negative. That's going to be a 3, so that's positive, and that's going to be positive down there. So we have an odd number of negatives again, which is 1, negative. So that means that's going to be negative. And then the last one here is 2. So when I plug in a 2 here, that's going to make it 4 minus 3 is positive. Okay. When I plug in a 2 here, that's going to be 6 plus 3. That's positive. And then it's 2 positive 2 on the bottom. That's going to be positive. So we get positive for that one. So now we have all the information we need because we went through all those test points to know exactly what we should write down. Because keep in mind here, now I just go back to the problem and I say, okay, we're less than or equal to 0. So that tells us then that we're going to be negative or 0. So that means I'm going to look at these intervals. And I'm using brackets here because it says equal to. Okay, and that means I include it. So now remember, I'm using the blue and the red here to determine that. And also I have this one. And remember that red was my asymptote, so I'm going to use a parenthesis there. And that's where the importance of that comes in. It would be easy to get mixed up and say, oh, I don't know, do I include that? Do I not include it? Remember, when they're asymptotes, they're not in the domain. That's why that value is there to begin with. Okay, and it looks like I go to 3/2, and 3/2 is a 0, an x-intercept, so I can include that one. So those are my intervals, and I kind of just drew them in there. So now I'm actually going to put the values in, and I'm just going to do it to the right of the problem here, so you can see it. So this is going to be negative infinity to 2/3 bracket. Oh no, I ran out of room. All right, I'm going to move it down here. Okay, there. Union. And then the other one is going to be 0 to 3/2. And I use a bracket there. And you can see that they just match up. All right, and that's what it should look like. Generally, I would write it below, but I didn't give myself enough room for that to write it below. So this is the answer for the second one. So that's how we work those out.